with this one that they'd like to see it? Basically, to do the mean, you add these 5 up. So, you add those numbers up. 11, 24, 24, 14. I add the positive ones first, and then 13 is negative. So we got 60, and then you divide by 5. And so the mean would be 12. The mode is going to be the repeated value. You can see that without ordering them, but the only repeated value is 24. Now, and I wish I could copy these. I just don't know why it doesn't like that. But I'm going to write on the board. The internet's going a little bit better today. Things were terrible. And I thought maybe it was just me. And then I got into another meeting on Zoom, like a non-class meeting, and it was terrible too. So I'm going to write them in descending order, or I'm sorry, increasing order. And you got to remember if you got a negative number, so it's got to start with negative 13. And then 11, 14. And so the median, the median is the one smack dab in the middle. All right. So let's see what else we got. I think number 2, it's pretty much the same thing. It's just got a lot of numbers on it. Let's see what it is. Is this a mean, median, mode type of thing? So with this, same thing. It's just got more value. So add them all up, divide by 15, then order them, find the one in the middle, and then the one that repeats. You could probably even tell that that's 220 because there's 4 of them. But there's one that I really want to show you, and I want to show you how to do it with the calculator, because the calculator is your best tool, the way we're running things now, especially for the midterm and the final. Because if you got that locked down, you're not going to be able to, to open up any other screens. For my test, first one, you can, but it doesn't really matter on that. Now, this is just one. It's not all that important, but this is what we call qualitative data. You can't calculate a mean or a median on this, but you can find the mode by just finding the one that repeats the most often. And you could just go through and count the one that repeats the most often. Not a really big, important issue. But here, let's see, is this the one I wanted you to see and use the calculator? All right. So this is the calculator that I showed you. I'd put it in a Canvas for you to download it. It'll only work on a Windows computer. There may be one for Apple somewhere. I don't know. And I'm kind of having to adjust some of these things because of the way we're doing things now. In the past, when we had, the paper final, what I would do is just tell people to use this on the computer, or you can also put the one on your phone. Because if you got an Android phone and then maybe an Apple phone, you can put on here, and I can even show you. I might have showed you my. Actually, I got two scientific. One's old timey, but this one right here. Hopefully, you can see it with that light behind me. But see, that's the same calculator, and these are the same ones that the book, the PowerPoint, and the helps or show you how to do it on. But like I said, I don't know what they have for Apple. But anyway, let me show you how it works on here. All right. So once you turn it on, you go to Stat, you go to Edit. Let's see if I can remember how to do this. There we go. So if you don't have anything in there, then it'll look like this. If you already had a previous data set, if you got to clear it out. But let's go ahead and put that one. And I'm looking at it from the, I still got that screen open. So it was 18, enter, 36, enter, 20, enter, 19, enter, oops, 16, enter. And then when you got them all done, then yeah, I just don't, phone a friend. That's the only thing. Personally, it's my belief that with statistics, you'd have to search high and low to find someone to help you anyway. So you see, I got them in there now. Here's the thing: is just when you do the what I would just say when you do the because when you go to the respondents check it first, you got to show your ID and then show what you got. So just have the the calculator and just show that, so you got nothing to hide. All right. So now we go back to Stat. Okay, the Stat button. That's the only place we've been so far. Stat Edit. Now we're going to go to Stat Calc. And now this is everything that we've done in Chapter 3, done for you for the most part, or at least everything that the HP will do. It gives you the mean up at the top. They call it X bar, but if this is a population, like what this one was, or this one said sample. So this was a sample. So then X bar is the sample, but the population mean and the sample mean are the same, so they only give you one. Now, these next two, I don't know what you would need those for, but they're in there. The next two down here, SX and sigma X, S of X is the sample standard deviation. Now, this problem was asking for the sample variance and standard deviation. As I said here, if it said population, then you would use the one there. It looks like they kicked over 6X. Okay, now here's what we got to do if we want to find the variance, though. This is why calculators don't solve all your problems for you. All right, they give you the standard deviation. If you scroll on down, you'll see they give you n, and then they give you that 5-number summary that we talked about last time. So it doesn't give you the variance. So if you're familiar, though, with what we talked about, the variance is just the standard deviation squared. So I'm going, since we wanted the population, I'm sorry, the sample variance, we're going to put in 8. And I'm just going to put the whole thing in there. You don't probably need to be that accurate, but you should always go a few beyond what it's asked for. It says go out to 2 decimal places. So we got to go several past that, because if you don't go past that, and you're going to lose your accuracy. So now let's go back to the problem. Oops, I picked the wrong thing. I went back to the calculator. Why isn't it going? Everything's still kind of slow. It's just certain days it seems like. No, why is it not? Did it come up? Let me reload that screen. Still not doing as well as it should. So, okay, oops. Okay, so what I'm going to do is I had 65.2 when I squared the standard deviation. So I'm going to put that in there. And then it was 8.07. Okay. So if you were able to put in that array and then hit the var stats, you got everything you need. Okay. So any questions about that process? Not yet. All right, let's see what else we can get into. So that's another one. This one is the population. So that one, you just pick the one that looks like they kicked over 6 and then square it for the variance. All right. The next one is the same one. I'm going to do that one since the numbers are kind of a little bit better. This one's dollars. Okay. So we got a large sample of customer accounts. A utility company determined that the average number of days between when a bill was sent out and when the payment was due is 28. That's the mean, and a standard deviation of 5 days. Now they're telling us, assume that the data is normally distributed. That's important because that means we can use the empirical rule. The empirical rule is one that's fairly accurate, and that's when they also call the 68, 95, and 99.7 rule. I'll throw up a screenshot of it if you don't remember it. I can't remember exactly what ours looks like, but it's not the way it looks that's important. It's just the, I think this is kind of maybe the way it is. But anyway, what the 68% represents, and that's the light brown tan or whatever it is. And we're talking about the one way over here, the biggest one on all the way to the right. That is 68%, and that's one standard deviation on either side of the mean. You see the mean is 0, 1 going over here, 1 going in this direction in the negative direction. So in between -1 and 1 standard deviation is 68% of the data. If we go 2 standard deviations, then we've got 95% of the data underneath there. And this is if we know it's approximately symmetric or normally distributed. Now, if we go out 3, then that's essentially almost all. There's a tiny little bit on either side over there, but it's not that much. It's 0.3%. So that's why up until chapter 3, they say almost all. Okay? So let's go back over to the problem. Okay, so part 1, it says between what two values will approximately 68% of the numbers of days be? Well, 68% is 1 standard deviation. The standard deviation was, and I'll just do some calculations over here. So I forgot what it was already. It was 28. And then this standard deviation is 5. All right. So we can say okay, so 1 standard deviation is just 5, so that's going to be 28 minus 5, and 28 plus 5. If it, for example, it had said 95%, then you would multiply the 5 by 2 to get the 2 standard deviations, and that would be 10, so you would subtract 10 and add 10. So then this ends up being 23, right? And 33. So in this case, for this particular example, okay? Any questions about that? All right, so we were told the key thing in that problem that the data was approximately symmetric. Okay, so let's go back. Oops, I thought I was sharing this page. All right, so, and just incidentally, if you if it's too small, make your click on that little thing all the way to the right of the share screen, that little with the arrows going out, the 4 arrows. That'll expand it and make it bigger. I don't like doing that because it takes, then I got to close it to get back to doing the things I got to do. So I got on glasses so I know it and I can see the actual screen. All right, so the temperature in a certain location was recorded each day for 2 months. All right. The mean temperature was 87.1 with a standard deviation of 47 degrees, 4.7 degrees. What can you determine about these data by using Chebyshev's inequality with k is equal to 2? Now, and somebody was asking about formulas. Let me just show you in case you've not seen them yet. For my tests, you can use this, and I don't care. I mean, you can print it out and use it for the midterm and the final. They just wanted to make it easier for proctoring, so they started building the formulas into the midterm and the final exam. So anyway, if you go over to the modules, everything you kind of need on here and more. So all the way down, it's below the PowerPoints. I put that down here because I generally don't tell people about this until you get halfway in the course, start looking towards the final. But this is this kind of boils it down to the most important things, because I think that people tend to think that if they can look through their book, that's going to make it easier. But the more stuff you have to look through, the more time it ends up taking away from test time. But if you click on this, So let's see, can I make this large? So for right now, everything that we've covered so far, that's as big as I can make it, it looks like. Well, actually, there we go. Is in the first two on the left there's your mean formula, whether you're dealing with the sample mean or the population mean, they're both calculated the same. That's the formula if that helps you. Here's the measures of the dispersion. These right here, the population and the sample variance. So to find the standard deviation, you take the square root of those. You don't have to worry about anything down there yet. That's chapter 4 and 5. Over here under miscellaneous, that's your empirical rule essentially. This is that thing we're working with, the Chebyshev rule right there. But the thing about the Chebyshev rule, it's really easier in a sense to use than the empirical rule because you only got have to worry about 2 and 3 standard deviations. This doesn't work for 1 standard deviation. So what happens is when you do 2 standard deviations, which they told us k is equal to 2, you do 1 over k squared, which is 1 over 4. 1/4 from 1 is 3/4. The range, this is something, I don't know why that's in there. You don't really need that. And then here's your IQR. That's the end of chapter 3. And then here's your lower boundary for outliers, the upper boundary. Here's the z-score solved for x. In other words, if you want to find a particular value, given the mean, the z-score, and the standard deviation, that's how you do it. But that's essentially just the z-score solved for x. And again, they got z-score twice, one for sample and one for population, but it's the same one. All right, so I just wanted to show you was there. So 1 minus k squared is what we want over there. So let me write down the things we know. Mean, all right. So k is equal to 2, and just to show you that, let's see if I can type this sideways. I don't think I'm going to be able to get it to you. I'll just go ahead and I'll write it in. In case you're wondering where I got this from. So that's our formula. And I don't really think most people need to memorize you don't need the formula because hopefully you recognize these. There's only 2 values. So so that's 1 3/4 or 75%. So that's always going to happen if you're talking about k is equal to 2 or 2 standard deviations. That at least, and that's the key word when to help you know when to use Chebyshev. They told you it was Chebyshev here, but sometimes they may say at least what amount of data. So when you see that at least, as compared to the empirical rule, they say, you know, what is it they say? Approximately. Well, here it's at least. All right, so that means that at least 75% of the data is between two standard deviations from the mean. So let me type that out. Just like we did for the other one, we got endpoints. Okay, so there's going to be our boundaries. So you folks go ahead and do those, and then we'll see if we've got, so it's 4.7 times. So that's 87.1 minus 9.4 and 87 plus. What happened? Just have to write it out. All right, so what do those two values come out to? What's the matter, Treva? On what? So that's what we can say. Hold on a second. Okay, so that's what Chebyshev can tell us about that at least 75% of the data is between 77.7 and 96.5. Now, because Chebyshev works with data that's not normally distributed, or if we don't know that it's normally distributed, in other words, approximately symmetric, it's not as accurate. That's why with two standard deviations in the empirical rule, you could easily say approximately 95% is between. So this one, it's just kind of a little bit less accurate because it says at least 75% of the data is between these two values. And the at least is the key word that lets you know you're dealing with Chebyshev. see what else we can get into. So if you think anything that you want to see, let me know, because I don't mind. I just want to be us to use the time productively. I'm just going to go through and pick the highlights of what I think is important, what I know to be important, and usually the things that people get stuck with. Mean set of numbers. I got more of those. All right. So let's, because that's 3.2. So let's. Can anybody think anything from chapter 2? Well, when you say use a phone, I mean you're using it for what reason? Okay, if you're going to do that, then when you go in and you establish contact on the respondus, you're going to show that. See, it's a calculator, so it becomes a calculator throughout the time that you're testing. Okay, you're not talking on it. All right, not texting on it. You're using it as a calculator. So anything people can think about further back? I mean, there's not a whole lot in chapter 1. I mean, it's important to know the difference between discrete and continuous data. Um, Sometimes it's important to know because you're going to see those words about when something is discrete, it's whole numbers only. And when you're talking about continuous data, it brings in fractional parts or decimal parts. And in chapter 2, um, it's really just important to be able to deal with the frequency distributions and the histograms. Matter of fact, let me go back and see if I can get. Well, I mean, I'm all on board about that. So that's why because the longer I teach, it upsets me that uh, it just we're throwing more, you know, monetary requirements and debt on people for wanting to study and something like that. If you can have something free, I'm all for it. Yeah, I mean it's at least $100, and when you're not going to use it outside of this class. And if you truly, if you were to go somewhere and you actually have to do this, you would do it, with some kind of computer program. Excel is a wonderful way to do it. So, like I said, but it's All right, can y'all hear me? I don't know. I had a little glitch or something. Can y'all hear me? And also, too, it's the one that I'm showing you is you can download it from Canvas there in the modules and use it on the computer. For my test, my first test, you can use it. Like I said, it's we just have to take it one step at a time because things are changing. So I'm trying not to stir up too many pots. Okay, so I'm just going to leaf through these, and I'll that's just talking about the type. The ordered one is called the Pareto chart, but well, you must be using the. Are you using the Apple? Because when it gets to Apple, I don't know anything about it, and I know it works different. I'm not sure. Well, yeah, so you're kind of on your own there. I don't think they have the Wabbit Emu on that, so it may be different. They may charge you. I don't know. All right. Is everybody all right on the frequency distributions? You want to work through one of these? Basically, I'll just boil it down to what you got. You're going to have to find out what the total is. It's an M&M's exercise. You get the total of all of these. All right. Then you take each one of these and divide by that total. Go out to 2 decimal places, and then you put them on there. Make sure you're rounding off to 2 decimal places, and your total will be 1. Oh no, stuff's starting to slow down now. It's going all right for a while. So this is the same thing, frequency distribution. But that's what a frequency distribution is, basically the M&M's thing. Because you're breaking down into the 6 different colors of the M&Ms. You're dividing the total number of M&Ms into each of the number for each color, and then that gives you the relative frequency or proportion, you can call it. All right. This is the kind of thing I wanted to look at.
Hey, Timothy, you're nothing but an egg while you're nothing but an egg while
All right. I don't know what's going on there. Why is this thing acting up now? All right. So can y'all see that? Why in the world is it like grayed out on my view? That's strange. Maybe it's just going to take a while to kind of. Okay, yeah, because I can see on both of mine. Yeah, it's grayed out. Let's see. Because the screen looks fine. Okay, let's see if it does it this time. It's rolling along there for a while. Like I said, I just think there's just certain days where the internet is just okay, good, overused, and I thought it was just me for a while. Okay, so this talks about unimodal and bimodal. That's one of the things that's important. If you've got two humps, like two camel humps, in other words, you can sit in between the two humps. They don't have to be exactly the same size, but that's what we call bimodal. Bimodal. If it's just one hump, then it's unimodal. So normally distributed or approximately symmetric data like this one. And it's taking its sweet time. Okay, so this one is asking whether it's skewed right, skewed left, or approximately symmetric. Now, if it's skewed left, then there would be, you wouldn't have all these bars coming down on the right. It's more or less like a mountain, straight up. You got a hump and then you come back down. So this has no clear tail. It's got tails on both sides. So this is what we call approximately symmetric. Okay, it's not perfect, but few things in life when you're talking about real data are perfect. So this is what we call, why they call it approximately symmetric. Later on, in chapter 6, we use the term normally distributed. All right, let's see what we can do here. Again, it's taking its sweet time. I guess I can do the roster. Well, let's. All right. Okay. Even though attendance is taking a while. All right. So, what are they asking about this one? The following frequency distribution histogram represents the number of trials that took each rat to learn the maze. So this is important because it's just asking about certain things. Along the bottom is the number of trials that it took the mouse. And then going up and down is the number of mice that were in that category. So in other words, the number of mice that took one trial, there was 2 of them. 3 took 2 trials. 3 trials, also 3. 4, there was 4 of them. 5 is 5. So some of these are the same going up and down. 6 trials, there's 5, and so forth going across. Now, when it says what is the least frequent number of trials, well, it's this one right here. That's the least one. That's the smallest one. So that's 1. How many rats learn the maze in 4 trials or less? So that means all of these 4 added up. So that's 2, 5, 8, and 4. So that would be 12. How many rats took 7 trials or more to learn the maze? 7 trials or more. So that would be these 4. So that's 6 and 7 and 7. So that's 20 because that's 14 and 6 is 20. So 28. All right. So let's see who's out there. Brittany, I see. I think I saw Trinice, right? Yeah. I don't get in mind after next week not to even bother with doing the roster. It just takes too much. Nia, I don't see. Taja Cavalier, I see. Dominique Daniels. Victoria Farrell. She's out there. Taylor Green. Yes. Gabriella. Gotcha. Ashton. I don't see. Diamond. I see. Karenisha Morris. Yes. Ruba and Treva Smith. Okay. So the only ones that weren't here were Nia and Ashton. So if you're out there, let me know. All right, let's go back. Well, did I already share it and then it went away? And this is the same kind of questions. Unless you want to see another one, it's pretty much the same kind of thing. Well, this one's talking about percentage. So what you got to do instead of doing the actual frequency is you do the relative frequency and then change it to a percent. So you got to find out. Well, they actually give you the relative frequency there. So the percentage of women with blood pressures above 110 is, so it's essentially all of these over here. So what you can do is add up all of these that are less than 110 or 110 or less. So these 4 and then subtract from 1. So let's see, that's, oh boy. What is that? I instantly don't have stuff like this on my test. This is just good to be able to read and see the percentages though. Let's see, what is that going to be? Each one of those is 1, 2, 3, 4, 5. Okay, so each one of them is 1. So 2%, 2%, and then 6, 7, 8. So that's 8, and then that's 10. So 18, 19, 20, 22. So it would be 78%. Well, it's probably 75. Let's count again. So that's 10%, 8%, 18, 19, 20. Oh, I don't know why they're just giving us those choices. Maybe I'm not seeing it right. But anyway, that's the general idea. Again, I'm going to belabor that kind of stuff. Just as long as you know how to read them. the one that we looked at first is going to be more important. You can even do that when it's a percentage that all right, so nobody's got any questions yet? So we don't have a Monday class, so we come back on Tuesday. We don't get any time off for Labor Day. So Tuesday will be another review. If you got any questions, please let me know or stick around. I'm not going to push you to hang in here unless you got questions today, since it's kind of a break. Assignment, like a homework, you can go back and do it. You just got to go down here and do it. It's doing that same thing where it's not sharing. All right, let me show you. Mine looks different, so but I know you can get to it if you missed it, because it just goes down. Like I said, yours is a little bit different, and there might be somebody in here that's figured it out. But once the due date goes by, then it disappears from up here. Okay. So what happens is, and mine works the same way. Then you go down here, and there's some way you can get into them because they're not closed. I think maybe it's through the grade book. Let's see. All right. I'm going to see if they got another one in there, because that one was kind of weird. I was trying to rush because we almost out of time. But let me see if I can answer this about the how to get into it. I think what you got to do is go into your grade book, and then you click on it and go in that way. I should be showing you all that. That's everybody's grade book. So I think that's the way you do it. So you can go back and work on any of the homeworks up until midterm. You can complete them all out. All right, let's look at that percentage one, and that'll be the last one we'll do. All right. Okay, here's a good one. It's got percentage on it. And this one's actually got them written out so we can see. All right, so here's one that's got it as a chart and not a graph, and this is going to be easier to do. And this is helpful because we need to know about classes and stuff like that. It's important to know how many. So, how many classes are there? Well, oops, you can't see it. I got to share it. And it's doing the same thing. Try it again. What? I've never seen that happen before. Like I said, I think there's some kind of elves or something got into the internet. But on the homeworks, as I said, you should be able to work on any of those up until somewhere around midterm, and there shouldn't be any penalty on any of those homeworks. You know, the due date are important for the most part for pacing purposes. Like tests, they got to be open for a certain window of time, and quizzes the same way. You can't do that with those. But all right, let me just reload this whole thing. All right, hopefully it'll come through. If it doesn't come through, okay, there. All right, so this is written out as a frequency distribution and not a chart, which is more important. Like I said, is that because that thing wasn't a very good example, like a histogram or anything. All right, so we got 200 folks, and they're put into these different classes, and it's just the number of hours per week that they spent playing video games. So the first thing is, how many classes are there? 1, 2, 3. And if this was put into a histogram, you know, the number of hours the classes would be along the bottom, and the frequency would be the vertical. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is something you got to make sure you understand this, because I had a question from somebody that didn't understand about the class width. The best way to tell the class width is to take any two right next to one another. You can do it right here with 1 and 6. 6 minus 1 is 5. So also is 6 from 11 is 5. So the class width is 5. All right, so now, percentage. What percentage of students play video games for less than 11 hours a week? So that means less than 11. So it's going to stop here, and we're only looking at these two, 10.9 and below. So that's going to be 26 plus 37. And then we're going to divide that by the total, which is 200. So that's 0.315. So 31.5%. What percentage of students play video games for 6 or more hours per week? So we got to make sure we identify the one we want. 6 or more is everything but this one. Okay? 6 or more is everything on down. The easy way to do that is, you know, they add up to 200. So you're just going to take the, and this is what I was trying to do with that one that was a chart. So then I'm going to subtract 26 from that. So I got 174 if I were to add the 9 frequencies down here below 26. So 174, and if I divide by 200, again, the total, that's your M&M thing, then that's 87%, 0.87. All right. This one only had 2, so, but it had multiple parts. All right, so that's enough. So if anybody's got any other questions,